Good morning, Kerbal Dots. I'm CW and we're back for some more testing. Testing? Hell yeah. Right. In previous two videos I mentioned that the mainsail can lift just over 2 large orange fuel tanks. Well, let's go find out exactly how much they can lift, shall we? We're not going to worry about killing Kerbals. Not today. It's April 1st. Screw it. Let's kill them. Kill them all. Hello. Make sure it's nice and stable. Oh, come on. Thank you. Right, so that is 2 orange fuel tanks. We know it's going to lift it. But let's do the test anyway, shall we? We also need to work out how high it's going to lift stuff, especially if we're lifting additional fuel. So I have grabbed the trusty notepad. So that's 2 orange tanks, which is, we'll just do the liquid fuel, and it's 5760. On the fuel, right, power up, SAS on, and launch. Oh my god, someone launched an IPBM. Oh, come on, interplanetary ballistic missile. A little bit of an overheat going on there, but whatever. So, we're up to 2000. Faster, 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 faster. Screw it, let's use physics warp. Oh, and that's just maxed out my processor. That's helpful. No, why the hell did you just kick over? No, never mind just kicking over. Now you will also notice that I have no control surfaces on there. So it's just the SAS that's keeping it straight and level. Simple reason being, control surfaces will generate drag. And if they generate drag, that slows down and alters the results. And the test isn't the same every single time we do it. So let's not do it. Right, first figure that we're going to write down is the point at which the engine cuts out. So drop back down to 1 times. And then we get rid of that. 80,000, 82,000. And then we sit and wait for it to, no we don't. So 1, 4, 3, 4. 1, 4, 3, 4. Wonderful. Revert back to the VA bay. Yes, I know there are add-ons that allow you, that let you do this without having to actually do this. But, that's just no fun. Let's skip that one and go straight for this one. Oh, darn it. Really? In the way? So we've just added an extra 720 on top of that. I want to get to the point where basically you're pretty much hovering. So, dreidel up, SAS on, and release. So the fuel on this one is 6480. I'm going to use physics warp again. So that maxes out my processor. Or processors. Don't know how you want to have a look at it. That's a kind of moot point. Processor or processors? Whoa. Really? What's just thrown that over? I didn't touch it. I'm going to have to redo this test. I'm going to have to stop using physics warp. It's either that or the developers have included wind shear into 0.23 without telling us. Let's drain that tank first. So it's not a nose weight issue. Oh well. You know, this is bog standard testing and Jebediah still loves it. Bob still hates it, and Bill, well, he's unhappy, but he's also quite curious. Is it me, or is his eyes lopsided? Oh, something just made my PC drop to a crawl then. Weird. There we go, it's kicked in again. What? I wonder if the developers did add a bit of wind shear in. If they did, it's not enough. Right, looking for the point where fuel quits. We may be ballistic here. 94,000 on that one. So we went from 82,000 to 94,000. Right, and the apogee is 1900. We went from 1434 to 1900. So let's do another test, shall we? So let's get rid of that one. We'll put that one on. Save, launch. Throttling up, SASR, let's go. So, weight of fuel this time is 7200. Now we'll see how high it gets. Now the fun thing about doing this is basically quite simple. As you're going up, air resistance will slow you down. If you have more thrust to overcome that air resistance, you will go faster. However, if you chuck a load of fuel on, the fuel drains at a set rate depending on your throttle setting. So we're using max throttle here. Right. Now, most people know do not exceed, what, 200 meters per second below 10,000? Well, by adding extra fuel on, you increase the weight, which slows you down, thus preventing you from exceeding 200 meters per second. But of course, as you get further up in the atmosphere, you've drained off a load of that fuel, so you end up going further. The flip side of that is you are carrying the weight of the fuel tanks, sort of. There is a reason for doing this demo and this test, and please bear with me. You can do this with any engine, by the way, not just the mainsail. Everything from the nuclear to, strictly speaking, you could probably do it with RCS jets. Right, 300 and that was 11,000 meters, which isn't too bad. Oh, I don't think Bill knows what to make of this. Apparently he's having flashbacks to different launches. Anyway, what was I saying? Oh yeah. Processor or processors? Well, you got to understand how the architecture of a processor actually works. Back in the good old days of 486s and when the Pentiums originally came out, everything was single core. Now, some of the fun thing was when you changed generations, then the capabilities of the processor changed. For example, the original Pentium processors did not have MMX on board, so the multimedia extensions for playing video and audio, etc., weren't there. You know, the nice little how can I explain it for a layman? Complicated words in the English dictionary, such as depression, I'll just pick that one for an example. It means a whole host. Bollocks. Oh well. That's weird. What the hell's going on here? Huh. I still have fuel left. That's better. Now it's gone. Weird. Oh well, I'll pick that up in the video in a minute. As I was saying, depression. It means a whole host of things. They're quite wide, varied. Same goes for processors. The MMX stuff, back in the good old days of the Pentium, simplified a hell of a lot of commands, and basically meant that a chunk of code, a couple of hundred or 1,000 lines long, could be simplified into maybe like 10 instructions. So same goes for the updates that we're using in processors today. The downside is that if your software doesn't use those extensions, then you don't get any benefit. So going back to the test, using 3 orange tanks now. Yeah, don't worry, I know I didn't get the first value for the lift. That's okay, I'll grab it off the video. Oh, that's slow. Wow. So, maximum fuel on this one is 8640. So yeah, I mean, modern processors have the SSE, SSE2, 3D now, all sorts of add-ons compared to the original Pentiums, which is great for programming, provided you use them properly. Now, that being said, the processor that I've got in my PC is considerably old. Getting on for what, 5 years now, I think? Yeah, it basically has a twin-core x64 processor. Now, the original debate that I mentioned was processor or processors. Strictly speaking, a multi-core CPU, while it shows up under Windows and the OS as multiple processors, it is just the core and not a complete separate processor. So you might think, oh yes, I'm running 8 processors in my PC. No, you're not. You're running 8 cores. One processor, 8 cores. What's the difference? Well, it's simple. Each processor has its own independent bus through the North Bridge to your main memory and to your hardware. Multi-core processors share the same bus. So your main bus speed is set to whatever the hell it is, unless you're like me and have tweaked your settings, then your main bus speed will most likely be the same speed as your memory, which is inefficient, but yeah, we'll come back to that. So yeah, your memory speed is significantly less than your actual processor speed. So your processor, as it's executing instructions, it will go and get the next set of instructions, the next set of data from memory. Now that doesn't always work brilliantly because it has to take an educated guess as to what's next. So basically it takes the program from what is essentially load speed memory, which is your main memory, and loads it into the level 3 cache, which then loads it into the level 2 cache, and then finally basically into the level 1 cache. And each time it goes up the levels of cache, the cache speed gets faster. So repetitive processes, if you basically program them right, will stay in the caches in the processor, so it can be executed extremely quickly. The problem is, these days, you've got some people that believe they are wonderful programmers, and when you actually look at the code, 120, when you actually look at the code, it's very sloppy. I was trying to find an analogy, and then realised that the one that I was going to say I couldn't use because, well, miners might be watching. So have a look at that one. So it's 3132. Well, am I going to completely max out the engine? Or should I? Yeah, go on, why not? We'll just completely max it out here. Don't think it's going to launch with that amount on it. Oh, only just. Let's do this test. Right, anyway, so as I was saying, anyone can grab like C++ and Visual Basic and all the rest of them and chuck together a little program that does whatever with bells and whistles and yada yada yada. But efficient programming really does sort of take style and finesse. I mean, I don't know any high-level programming, really. Well, not allowed to say that I was extremely versed in. However, all the programming that I do are for Moho. Yes, I was thinking about going to Moho. Try again. All the programming that I do are for microcontrollers that basically have a low CPU speed, low amount of memory on them, and therefore you have to have extremely efficient code. Now, a lot of people love to use Arduinos, which is fine, go right ahead. They think it's brilliant that they can just go and grab an Arduino library for interfacing with a piece of hardware and slap a bit of code together and hey presto, it works. wonderful, it works. But when you start taking multiples of those devices and talking to them at the same time, when you take several of those devices along with an LCD, a serial uplink, let's say temperature sensor, humidity sensor, wind speed, precipitation, barometric, add on an LCD, add on data logging to SD card, and by the time you get to that point, the microcontroller is going to struggle if your code isn't efficient. So, I mean, that's going to be going way above people's heads, but it comes down to quality of coding. Now, personally, I absolutely love and adore Linux-based PCs and servers. I personally fully endorse any Linux server. There's only one thing that I haven't yet taught myself how to do with Linux that I can do under Windows. And even then, that's kind of a grey area. The downside is that any software built for Windows, specifically, will not work under Linux unless it is recompiled. KSP, for example, has a macOS version, Windows version, and a generic, well, I think, is it Debian? Something like that? Debian Linux version. Now, strictly speaking, macOS 10 and above is Linux. But, just sidetracking here, Apple have recompiled it to their own standards, which makes it, well, at best, non-standard Linux. But still, just because you're running two different operating systems, same again, 8K, just because you're running the same physical hardware, 9360, does not mean that programs on two different operating systems will run, even though it's the same hardware. That's weird. That's a lower apogee. Oh well. Right. That's all the testing done. I will be back in a shake of a lamb's tail. Hi guys. Right. So we have our 5 tests there. Same mainsail, just chucked on additional fuel. So everything was the same except for basically adding on fuel tanks. So we've got the cut-off data, and we have the coast data. So now we do a rudimentary calculation for efficiency. Basically, fuel quantity versus cut-off height. So the cut-off height in thousands of meters divided by fuel quantity, whatever unit that is, which basically gives us the average height gained per unit of fuel. So in the first test, we have 5760 units of fuel. Cut-off height was 82,000. which means the efficiency is 14.23 meters per unit of fuel. Second test, 6,480 units of fuel. We got to 94,000 before the engine cut off, which gives us a cut-off efficiency of 14.50 meters per unit of fuel. Third test was 7,200 units of fuel. Cut-off height, which I've just gone in to have a look at the video for, is 102,000 meters, which gives us a cut-off efficiency of 14.72 meters per unit of fuel. Whoops, I've just erased some of my data, hang on. That's not what I wanted to do. At least I wrote it down. There we go. Right, fourth test was 8,640 units of fuel. Cut-off height was 120,000 meters. Believe it or not, cut-off efficiency was 13.89 meters per unit of fuel. And the last test that we just did is 9,360 units of fuel. Cut-off height was 128,000 meters, which gives us the efficiency of 13.68 meters per unit of fuel. So from that testing we can determine that the absolute most efficient use of weight, thrust versus weight, is if we load it down with 7,200 units of fuel, which gives us the best cut-off efficiency of 14.72 meters per unit of fuel, which we like. So next video we are going to use that data. Bye for now.